Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, we are going to talk about concept of mixtures. So types of mixtures, there are two types of mixture, homogeneous and heterogeneous. Homogeneous, for example, two solutions, and heterogeneous, for example, coarse and colloidal dispersions. Friend, homogeneity, something evenly distributed. Something evenly distributed is known as homogeneity. You have to maintain the homogeneity. And heterogeneity, something not distributed evenly in a space or clump or cluster, not a single phase as in case of colloidal and coarse dispersions. So friends, in this slide, you have to clear your concept concerning to homogeneous and homogeneity and heterogeneity. So now definitions of a solution. A solution is a homogeneous mixture of two or more substances, or a solution is a homogeneous mixture of solute and solvent, or a solution is a homogeneous mixture of two substances but consisting of one phase. So a solute is dissolved in a solvent. Solute is the substance being dissolved. Solvent is the liquid in which the solute is dissolved. An aqueous solution has water as a solvent. So my friend, binary solution. What is meaning of binary solutions? Make your concept clear. A homogeneous mixture consisting of one phase. One phase is important. One phase and containing only two components. That is one solute and one solvent. Example, solution of sodium chloride in water. So dilute solutions. What is the meaning of dilute solution? A solution containing relatively a small quantity of solute as compared with the amount of solvent. Concentrated solution. A solution containing large amount of solute in the solution than that in dilute solutions. And a saturated solution. What is the meaning of unsaturated? Unsaturated means a solution in which more solute can be dissolved at a given temperature is called as unsaturated solutions. My friend, what is saturated solution? A saturated solution is one where the concentration is at a maximum. No more solute is able to dissolve at a given temperature. My friend, you make your concept. A saturated solution represent an equilibrium. The rate of dissolutions dissolving is equal to the rate of crystallization. The salt continues to dissolve but crystallizes at the same rate, or under these conditions, the number of molecules leaving the solute is equal to the number of molecules returning to the solid phase, and that is the solute. My friend, what is the meaning of supersaturation solution? This is very important term. Make your concept clear. A solution that contains relatively larger amount of solute than that required for saturation. It is prepared by heating and adding more and more solute. My friend, types of solution based on physical state of solute and solvent. A state of solution, a state of solvent, state of solute. Example, gas, example here. Liquid, gas, oxygen in water. Liquid, alcohol in water. Liquid, solid, salt in water. Solid, gas, hydrogen in palladium. Solid, liquid, mercury in silver. Solid, silver in gold. Gas, solid, smoke in air. Gas, liquid, water, vapors in air. These are examples. This is one examples you have to remember so that your concept will be clear. So my friend, solutions, how does a solid dissolve in a liquid? What drives the dissolution process? What are the energies of dissolutions? So how does a solution form? Solvent molecules attract to surface ion. Each ion is surrounded by a solvent molecule. Enthalpy changes with each interaction, broken or form. You can see ionic solid dissolve in water. So how does a solutions form? The ions are solvated, surrounded by solvent. If the solvent is water, the ions are hydrated. The intermolecular forces here is ion dipole, you can see here. So dissolutions versus reaction. Dissolution is a physical change. You can get back the original solute by evaporating the solvent. So if you cannot, the substance didn't dissolve, it reacted. So degree of saturation, A saturated solution's solvent hold as much solute as is possible at that temperature. Undissolved solid remains in flask. Dissolved solute is a dynamic equilibrium with the solid solute particles. You can see the water in sodium chlorides. So degree of saturation, unsaturation solution less than the maximum amount of solute for that temperature is dissolved in the solvent. No solid remains in flask. My friend, degree of saturations. My friend, degree of saturation, supersaturated solvent holds more solute than is normally soluble possible at that temperature. These solutions are unstable. Crystallizations can often be stimulated by adding a seed crystal or scratch the side of the flask. My friends, stages of solutions process, separation of solute must overcome IMF or ion-ion attraction in solute, required energy endothermic. Separation of solvent must overcome IMF of the solvent particles, required energy endothermic. Interaction of solute and solvent, attractive bonds form between the solute particles and solvent particle, solvation or hydration where water solvent release energy exothermic. My friend, dissolution at the molecular level. Consider the dissolutions of sodium hydroxide in water. You can see separation of solute molecules, separation of solvent molecules, and formation of solute-solvent interaction of system. So, initial energy of system and final energy. So, types of heterogeneous mixture. A suspension. A suspension is a mixture in which particles of a material are dispersed throughout a liquid or a gas but are large enough that they settle out. The particles in a suspension are large enough to scatter or block light. A suspension can be separated by passing it through a filter. My friend, suspension, you can see different components are in different phase, such as solid in liquids or liquid in gases. It is necessary to shake the substance before using it. You can see these injections. So colloids is a mixture in which the particles are spread over throughout but are not large enough to settle out. The particles are not as small as those of a solution, however, are smaller than those of a suspension. So colloids, particle in a colloids are large enough to scatter light. A colloid cannot be separated by passing it through a filter. So colloids consist of two separated phase, dispersion phase or internal phase, and continuum phase or dispersion medium may be solid, liquid or gas. Some are translucent because of the Tyndall effect. You know the Tyndall effect, which is the scattering of light. You can see in this picture. So my friends, solutions, colloid and suspension. You can see the homogeneous, heterogeneous and heterogeneous. Solution in which dispersion or consist of a small molecules or ion evenly distributed. Solution in which dispersion consist of single large molecules or group of a small molecule. In a heterogeneous solution in which dispersion or dispersion consist of group of large molecules not evenly distributed. Then particle size, then do not separate on standing, do not scatter light, and Tyndall effect colloidal solution. So my friends, you can read it thoroughly. So ultrafiltration is a separation process using membrane with pore size in the range 0.1 to 0.00 micron. Typically, ultrafiltration will remove high molecular weight substances, colloidal materials, and organic polymeric molecules. Low molecular weight organic and ions such as sodium, calcium, magnesium, and sulfate are not removed. My friend, heterogeneous mixture. You can distinguish the two or more phases. You can see. Gases in solution. In general, the solubility of gases in water increases with increasing mass. Larger molecules have stronger dispersion forces. You can see here. So gases in solution. The solubility of liquid and solid does not change appreciably with pressure. The solubility of gas in a liquid is directly proportional to its pressure. So Henry law, where Ag is the solubility of the gas, K is the Henry law gas law constant for that gas in that solvent, Pg is the partial pressure of gas above the liquids. So a certain temperature, the Henry law constant for N2 is if N2 is present at 3 atm, that what is the solubility of N2. Then you do the calculations. Correct answer is like that. Henry laws, Sg is equal to kpg. You know Sg is equal to this amount. You have this pg, you will get the Sg. So another questions. So my friend, temperature. Generally, the solubility of solid in liquid solvent increases with increasing temperature. So temperature, the process is the true of gases. Carbonated soft drink are more bubbles if stored in a refrigerator. Warm lakes have less water dissolved in them than the cool lakes. So concentration expressions. My friend, 5 ways of expressing concentration: mass percentage, molarity, molality, normality, and mole fractions. This is very basic. So mass percentage or percentage expressions. Mass percentage of A is equal to mass of A in solution, total mass of solution multiplied by 100. So this is the question. Determine the mass percentage of hexane in solution containing 11 gram of butane in 110 gram of hexane. So my friend, correct answer is this 4.91. So you can calculate the percentage mass of component is equal to mass of component in solution divided by total mass of solution multiplied by 100. Thus 110 grams divided by 110 gram plus 11 gram multiplied by 100, you will get 91%. So percentage condition, weight by weight, weight by volume, volume by volume. Then we can only multiply it: mass solute, mass solution, mass solute, volume solution, volume solute, volume solutions, and all multiplied by 100. So percentage weight by weight is expressed the number of gram of solute per 100 grams of the solutions. You have this 10% W by W equals glycerin solution, means 10 gram of glycerin dissolved in sufficient water to make overall 100 gram of the solutes. My friend, percentage by volume is expressed number of milliliter of solute per 100 milliliter of the solute. Weight by volume. So volume by weight, part per million and part per billion. It is very important. This is another way to expressing concentration, particularly those very dilute solution. Example expression: the impurities of substance in water. ppm denotes the amount of given substance in a total amount of 160, means almost 1 lakhs solution. Example: 1 million per gram or 1 part in 10 to the power 6. ppa denote the amount of given substance in a total milligram, means 10 to the power 9. So part per million and part per billion. Part per million, a mass of A in solutions, total mass of solution multiplied by 10 to the power 6. Part per billion, mass of A in solution, total mass of solution 10 to the power 9. So this is the questions. Correct answer is this. You can calculate it. Now friends, the molarity. So it expresses the number of moles of solute dissolved per liter of the solution. You can see M is equal to moles of solute, liter of solution. Molarity given weight, molecular weight substance multiplied by 1 by volume of solution in liter. So 1 mole of sodium chloride is equal to 58.5 grams of sodium chloride. Number of moles is equal to given weight divided by molecular weight substance. Because volume is temperature dependent, molarity can change with temperature. So concentration, molarity examples: if 0.435 gram of KMnO4 dissolved in enough water to give 250 milliliter of solute, what is the molarity of KMnO4? As is almost always case, the first step to convert the mass of material to moles. You can see here 0.435 gram KMnO4 divided 158.0 gram KMnO4 multiply 1 mole of KMnO4 is equal to 0.0275 mole KMnO4. So my friend, you can see the process. You can weigh it. You have the volumetric flux, then you add the solid, then add the water, and then swirl it, and then you cap it. So now the number of moles of substance is known. This can be combined with the volume of solution, which must be in liter, to give the molarity, because 250 milliliter is equivalent to 0.250 liters. So you have this molarity of the KMnO4 solution. So my friends, if you like this video, then subscribe my channel, and thanks for watching. I will make video for you, and if you subscribe, then it give me more and more energy to make a good video for you. If you really like this video, then subscribe my channel, and thanks for watching.